packet. Yeah, I think it's page 30, right? Because we did this page yesterday.
Oh wait, I'm in my homework packet.
Oh yeah, the homework packet would definitely be smaller, so that would make sense. Yeah, so get the notes. It's just the one we were working out of yesterday. And then we got through number 4. We're just going to do number 5 and then 6. All right. All right. So with this one now, it's similar to how we started yesterday. So let's kind of draw in a rectangular garden again. So we'll draw that in over here. And then this time, instead of guessing and checking, we're going to set it up using variables. So when it says use all 3 methods, solve this to determine the dimensions of a garden, that will be 16 feet squared. So the 2 sides better multiply to be 16 feet squared. And then it has a length that is 6 feet longer than it is wide. So,
Do you want to share your screen?
oh yeah, good call there, Kim. Good call. I thought I already had done that. See, everybody's ready for the long week, long break. All right, hopefully it pops up here in a second. You may hear kids running around and yelling too, because my kids are off school today, so I don't know if you heard that or not, so I apologize ahead of time. You can see it now, right? Okay. So it says use all 3 methods of solving to determine the dimensions of a garden. That'll be 16 feet squared. So I put 16 feet squared, that's the area. And then we want the length to be 6 feet longer than it is wide. So we don't know either one of them. So if let's say we made our width the x, then our length, so this would now be how long it is. It needs to be 6 feet longer than the x that we just assigned for the width. So whatever that x would have been, we want the length to be 6 more than that. So 6 more would just mean we want to increase that by 6. And then it's all with the idea that the length times width is equal to your area that you know. So we now take our length and our width, so the x and the x plus a 6. When we multiply those 2 things together, we want them to equal 16. We can then distribute x times x would give us x squared, x times 6 would be 6x, and then that's going to equal a 16. But then kind of recall what we had talked about yesterday in regards to standard form, where standard form is we want the squared term, and then we want the x term, and then our constant all set equal to 0. So currently this constant on the right-hand side we want to correct. We want to move this over. So we would do that by just subtracting it over. X squared plus 6x minus 16 equals 0. And then this is now where we can start doing those methods. So the method we would prefer, so again, eventually as you get to just pick these, factoring would be the method you would try and do first and foremost because it's the quickest and it's the easiest if it works. So in this case, what we are hoping is there is a way to multiply 2 binomials together. So the x squared can only be gotten by doing the x's multiplied by each other. And then we're looking for those 2 numbers that multiply to be a negative 16. At the same time, they're going to add up to be a 6. All right, as long as we have those, then we can factor this pretty quickly and get our answers pretty quickly. All right, in this case, we can. So a positive 8 and a negative 2, if you multiply those together, they multiply to be a negative 16, and then they're going to add up to be an 8. Now, when we solve these, a couple things. We solve these normally, so we think, all right, what x value would make that into a 0? So this would have been a negative 8. And then the same thing with the other one, what x value is going to make that equal to 0? And then that's going to be x equals 2. When we do this, though, what we have to understand is now the context of this word problem. So if we're solving this problem here, and we want to find the dimensions of our garden, can we have a dimension of a garden that's going to be a negative 8 feet? No, all right, we can't have a negative length. So when we're solving this now as a word problem, it's a little bit different than just doing this algebraically. We can't consider this to be an answer if we're talking about the lengths around a garden. So while the algebra gives us 2 answers, the only possible answer is this x value of 2. All right. Now, we also want the dimensions, so we want both of them. So let's kind of come up to here. We now know that x is a 2, right? So we're going to put the 2 right here. And then if I now ask you, what does our length have to be? It's going to be 2 plus 6. So then we would now have a length of 8. All right. So the way we would write this now is our width would need to be 2. Our length would need to be 8. It satisfies both things. It's 6 bigger. And when you multiply them together, they're going to give you 16. All right. All right. So then from there, the whole completing square, where now we're going to go ahead, take that x squared. All I'm doing is I'm going to recopy this equation in standard form. We're just going to rewrite it. And then we want to make a perfect square. So that's where we took the x squared and the 6x, and then we ignore that 16 for the moment, and we make a perfect square out of those x squareds and 6x's. All right, so if we did that, we would take this 6x, if we were to draw out our square, and we would have put 3x's here, we would have put 3x's here, so I would have had a 3 multiplied by a 3. So to make that a perfect square, we would have wanted to add 9. And if I'm going to add 9 there, I need to subtract 9 on the backside. So if we then look, what we would have had was an x plus 3 on top, an x plus 3 on the side. So this becomes x plus 3 squared. And then when we now combine the negative 16 and the negative 9, it gives us a negative 25. All right, then we solve this like we've now been doing with these square root problems. I want to move this negative 25 to the other side of the problem. So we want to add 25 to both sides, so that we get that x plus 3 squared equals a positive 25. The reason we do that is so that we can then get rid of the squared term by taking the square root. So then you take your square root, and we get x plus 3 equals a positive and a negative 5, because that's the square root of 25. All right, from there we set up our 2 different equations. Well, actually, we're going to add 3 real quick to both sides. Those will cancel. So what I now end up with is a positive 5 and a negative 5 increased by 3.
Let me subtract it. Subtract the 3 from both sides.
Oh yeah, good call, Cam. See, I am ready for.
You're all good.
Yeah, thank you.
You had a long Thanksgiving, but get your mind back.
That's right. I need it, I guess. I need the break. Losing it. Yeah, then we want to subtract 3 there. I guess I would have figured it out here, because what we should get, we better get 2 and negative 8, right? Like, we know we better get those same exact answers. All right, now we will. So for one of the answers, if I do it over here, we would do x is the positive 5 decreased by 3. So that's going to give me the 2. The other answer we'll do over here would be if it's a negative 5 decreased by 3, that gives me the negative 8. And again, same answers that we get when we solved it over here. But again, if we're solving this as a word problem now, just remember, we would not want to consider this as an answer. You don't actually put that down as a solution if we're answering how long a garden could be, because we know we can't have a garden that has a negative width of 8. Okay? All right. Then the last thing here, this homeworks are much better looking at them today. Looking at them this morning from last night. So going through the quadratic formula looks better. So that's good. We will probably have a quiz on this when we get back at some point. This is we've quizzed on the previous couple of methods. I haven't given you a full quiz with these just yet, but homeworks look a lot better with these. All right. So if we identify our A, B's, and C's, the A would have been a 1. The b would be this 6 here. And then the c would have been this negative 16 right here. All right. Most of us are pretty good with these. You can go ahead and start plugging these things in. So negative b is a 6. The opposite of b should be a negative 6. And then we do 6 squared minus 4 times a negative 16. All divided by 2 times a. So negative 6 plus minus. The 6 squared here should give us a 36. Still a few of us, when we came across these, are giving me these negative answers, but for the most part, it's a lot better. We're understanding this is a negative 4 times 1. That's a negative 4. And then that negative 4 times a negative 16 should give you a positive 64. Other thing we've talked about, if this factored, which it did, right? We were able to factor this. We were able to get rational numbers over here. That means this better be a nice perfect square. So this has to be a nice number that I can actually take the square root of. We would fully anticipate that. And it is, because when we add those, you're going to get 100, square root of 100, which then we know is really a plus or a minus 10, and then over your 2. All right, from there we get our 2 different answers. By doing a negative 6, we would add 10 for one of them, and the other one we've got to do a negative 6 and subtract 10 for the other. This is a 4 divided by 2, so this is the fraction that gives us 2. This one would have been a negative 16 divided by 2, and a negative 16 divided by 2 is the negative 8 that we're supposed to get. But again, if you're solving this as a word problem, we would ignore this guy and just indicate that that cannot be an answer, all right, because we can't have a negative blank. If it's not a word problem, then that's an answer. If it's a word problem, then we just have to make sure that our answers are going to make sense, all right? All right, so then the last one here. Where it says, determine which two best methods allow you to solve this quadratic equation now. So if we look, let me create a little space. This is in standard form. This is in the form that we want it to be in. We have our square term, we have our x to the first term, we have our constant. It is all set equal to 0. So typically, what we would like to have happen is that we could factor this. So let's come in down here and see if we can factor this. So we would try to figure out x, and x would give us x squared. And then we're looking for the 2 numbers that would multiply to be a negative 16. But at the same time, they would need to add up to be a positive 10. All right, and if we can find those in this factors, that's what we're now going to write down. Okay, anybody finding those? All right, good. See a lot of people punching in, shaking heads no, and that's good because this can't factor. That is not one that we can factor. So because of that, we have to then, that's why it's saying which 2 best methods could we use? That now forces our hand. If it doesn't factor, and as you're given choices, now you have to do either completing the square or the quadratic formula if it doesn't factor. All right, so now, what this also tells us, so we cannot factor. What this is also going to tell us is our answers are irrational. So now that this doesn't factor, these should not be nice answers at the end. All right. Now, it says determine the 2 best. I don't even ask you to do the 2 methods. So we're just going to do one method just to prove that these answers are going to be irrational since it doesn't factor. So we could pick any method. I don't even ask you to necessarily do them, but we're going to do one of them. So, Ahmed, which method do you want to do, Ahmed? What do you like best, the completing the square or the quadratic formula?
I want to do the quadratic formula.
Sounds good. That's probably what I would have picked. So he now, since these, well, let's answer this question first. We either have to complete the square. Let's answer the question. Or we would have to do the quadratic formula. If it doesn't factor, those are your only options, okay? Ahmed has chosen the quadratic formula. That's probably what I would have done. And again, keep in mind now, we better get an irrational number, so that means there should be a radical in our final answer. It's not going to work out nicely like the previous couple problems, okay? So let's set this up, answer this, and then be on our way for the week. All right, so B, if we look up at our equation here, should have been that positive 10. So if I want the opposite of B, that would be a negative 10. Plus or minus 10 squared. And then minus 4 times A. A would have been the 1 right here in front of the square term. C should have been the negative 16 right there. And then all over 2 times A is a 1. So negative 10 plus minus 10 squared is a 100. When we multiply all these together, it's a negative 4 times a negative 16. So that is a positive 64. All divided by 2. We should know 164 is not a perfect square. If it was a perfect square, then we would have been able to factor over here. That means we have to now try to see if we can just simplify that. Find two numbers that multiply to be 164, with one of them being a perfect square. It's actually not that bad. Keep in mind where your perfect squares are. And so you really just start, you don't really ever want to start with 1. But 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. So just start taking 164 divided by 4. See if that works. If that doesn't, then you go to 9. If that doesn't, you go to 16. But we should have found pretty quickly that the 4 does work, right? Yep. And it would be 4 times 41. 41 is a prime number. There's no way we can simplify that. So then from there, we do negative 10 plus or a minus. This square root of 4, we now simplify down to be a 2. And then our root 41, all divided by 2. Again, come quiz, test time. If I have, it's one of the ones where I want you to kind of just show your work and I want to see the answer. I would take this as an answer. This is not wrong. So if you were to write that down on a test, quiz, assignment, totally fine. But if it's on a quiz and it's multiple choice, or a test and it's multiple choice, I'm going to give you the most reduced answer. And this does reduce, because if we look at this number, all the non-radical terms, all 3 parts can be reduced by a 2. So because of that, then we would want to reduce all of them by 2. So the negative 10 divided by 2 turns this into a negative 5. Actually, let me not change all those. So let me just leave this. If I take this 2 and divide it by 2, then that just becomes a 1, root 41. And then if we take the 2 into the denominator, divide that by 2, you're just going to get a 1. So then, since it's all a denominator of 1, the answer, multiple choice wise, you would just be looking for this. All right. And again, we knew we were going to get this irrational number. The reason we knew it was going to be irrational is because we didn't factor it. If it could factor, then we know we're going to get a rational number. All right. Okay, with that, that's all we got. Okay, we just want to make sure we got through that so that we, again, can get everything done by the end of the semester. So there's no homework. Our Thanksgiving gift to you guys is 13 minutes of uninterrupted time before your next class. So have a good break. Have a good Thanksgiving. All right, and we'll see everybody on Monday. All right.
Have a good break, everybody.
All right. See you guys.
There's a lot more cameras on that, I thought.
Yeah. Troy, are you there? Well, let me.
I'll let you remove him.
What's that?
Won't let you remove him?
No. It says it, but when I click on it, it won't get rid. Let me stop sharing. Sometimes if it just, if I got too much stuff going on, it won't let me.
Yeah, I don't know if it was
I'm
your
gonna.
internet or mine. Every once in a while, you would freeze for a few seconds.
It could have been mine because I thought the same thing. There was twice I was going to ask you, can you hear me?